In this video, we're going to pull together all of the different syntheses that you've learned over the organic course, and we're going to put them into exam-style questions and show you how you can revise synthesis in a simple and easy way. Now, first of all, we have this fairly intimidating map, which is the aliphatic chemistry synthesis map. I actually really enjoy synthesis. It's a wonderful part of the course, and if you do it more often, you will start to enjoy it too. Now, you have to learn all of these different reactions and all the conditions and things like that, and you have done throughout the course. But to revise it, one of the really good ways is to have this printed out, for example, but have all of these being blank. And so, for example, in the alkene area, you draw an alkene. You just make up an alkene. So I'm going to make up an alkene, which is propene. And then I'm going to look on the map and go along to the alkane. Well, now I'm going to draw the corresponding alkane to this alkene and know that it's H2 and nickel and 150 degrees or 423 Kelvin. And that becomes your propane. We then follow the halogen going down to the haloalkane, okay, which is 1-chloropropane. And then we follow this sodium hydroxide nucleophilic substitution to make it into our alcohol. If you recognise that, hopefully you can see that's a primary alcohol. So we're going to get rid of the secondary tab here. It's a primary. Primary alcohols go down to aldehydes when you oxidise them with potassium dichromate. And they make the corresponding aldehyde, which is propanol. Now I've just done a section from here down to here. You can do all of it, okay? And it will work really, really, really well and get it into your head and do it multiple times. There is also an aromatic chemistry synthesis map in which you can do this as well, which is a bit simpler, but I would recommend that you do both. And both of these maps are attached to the video. Let's now talk about the different type of synthesis questions that you can get. So, first of all, synthesis questions are always going to turn up. There's no chance that you will not have to do these. You will have to do them in the exam, and they're quite common. So they split into three different types. The first one is arguably the most difficult, which is the level of response, but if you train yourself on it, it can actually turn into the easiest one. So the level of response is in three parts normally, level 1, 2 and 3, and it consists of three things they may ask you, which is 1, for the correct synthesis for what you're doing, 2, for the yield calculation, they'll give you some numbers, and for the type of purification that you might have. So 3 different parts to answer, and we'll practice that later. We then go for the other type, the multiple choice question. That's just, for example, if they give you a reaction and they say what are the conditions, they list them, or they give you the conditions and the starting material and they'll ask you to pick one of them as the product and have the reactants, for example, the conditions and the product, and then ask you to draw the reactants or, for example, to pick the reactants from 4 different types. But we'll go over that type when we do one in the video. So, last one is a multi-stage synthesis. Now these are always in the exam, and these are based upon just multi-stages, and you have to fill in the reactants and the products and conditions all the way through. Okay, but we're going to do an example of all of these to give you an idea. Now, what I would also recommend is that because this is learning all of the different syntheses, make yourself up a quiz. Do it with friends. So write out 10 questions related to the reactants or conditions of different syntheses that you come across. And ask your friends questions about them to try and get this in your head. Put it on post-it notes. Have it up on the wall. Make it regular. It's about memorising all these conditions. It's really important. Anyway, let's do the multi-stage synthesis to begin. The flowchart underneath shows a polymer A, which is starting from methyl benzene. You can see we're normally given a box, and inside that box we're normally asked to draw some form of reactant. And then normally we're given the lines for the conditions, or for example, for a catalyst. We then have that go into another box, and then that goes to a product, and there's some conditions for that. And then we have our final polymer A. So this is a typical multi-stage question, okay, which, as I've said, you will get in the exams. Now let's make some space, okay, and let's start to do it as we go along. So we're going to do the first one and think about what we're doing here. We've got a methyl, okay, here, and that methyl is up here. Okay, and then this new part here. So this new part starts here, here, and this is an acyl group. Okay, so two carbons and a carbonyl, an acyl group. So hopefully you're now starting to think that might be Friedel-Crafts acylation. Now, if you remember back, and again, there's nothing to stop you stopping the video, doing this before I do it, and I'll confirm the answers. Okay, so the first thing is going to be aluminium, okay, because we are going to use aluminium chloride as our catalyst, okay, and then we think about what group we need. Well, if we're doing acylation, we need an acyl chloride, okay, so the acyl chloride is going to be like that, and there's our acyl chloride. And we've got our acyl chloride there. And that would create that. Let's go across to the other side and have a look at this one going down here. So we know that this is going to an unknown product, which is then going to go into an alkene. So this is the alkene part that's changing right down here. So this alkene part is changing. So we need to turn essentially what looks like a ketone here into an alkene. Now, if you think about it, if you want to change into an alkene, there's only certain ways you can go from to an alkene. Now, the way, if you look on the map, is to go from an alcohol. So you can go to an alkene from an alcohol, and you don't really go to an alkene in any other way. So you do that by dehydration. So if we that means if we redraw this, but do it as an alcohol, okay, so I'll start here. So there is our benzene. Okay, so there's our benzene. We're going to put our methyl group on the side here, and then we are going to do our OH, and like that. Okay, so let's just make that a bit bigger. So there's our OH. Now we can look inside here and say, what do we think this actually is? We need to turn a ketone into an alcohol. And if you're turning a ketone into an alcohol, that is going to be NaBH4, or sodium tetrahydroborate. We then want to go from an alcohol to an alkene. If we want to go from an alcohol to an alkene, it is H3PO4, okay, and it's a high temp. Okay. So again, that is dehydration, okay, and really important. So we then go to the polymer. So here you've got a double bond, okay, that means it can do addition polymerization, it means the double bond breaks, and then the double bond will form this repeating unit. So there we have that. We know that the bond breaks, so the bond is going to break. Where the bond breaks, you put the extra bonds in, okay, and that is our repeating unit. If I just don't forget the methyl that comes off the top, okay, and that's our repeating unit. Okay, so we have got methyl benzene going for our Friedel-Crafts acylation, going to this new acyl group. This ketone here will then get reduced with sodium tetrahydroborate, which will then get made into your alcohol. Your alcohol then gets dehydrated via H3PO4 to the alkene, and the alkene then creates a repeating unit here. Remember, if you're doing skeletal formula, you've got to do them as dashes or dots, otherwise it looks like a bond. And that is an example of multi-stage synthesis question. We've now gone through a multi-stage synthesis example, of which you can practice lots in past papers. Okay, and we're going to try a different type now, which is the multiple choice question. So this is the way it can be presented, which is which chemical can react with phenol. So you can imagine this being done with all type of different ways. And the main thing is you must remember all of the reactants and the conditions. I cannot reiterate it enough. Okay, so which chemical can react with phenol? We've chosen something that people often forget. So first of all, let's look at potassium. Okay, so potassium does react with phenol, So does potassium hydroxide. So potassium and sodium hydroxide. They normally say potassium because in the books you'll find they say sodium and sodium hydroxide. They don't say potassium, so people assume not. But basically it's a group 1 metal, so it will do the same thing. So it does react with your phenol. Ethanoic acid doesn't react with phenol. The reason it doesn't react with phenol because it's not strong enough in terms of reactivity to react with a phenol. You need something more strong like an ethanol chloride. And that's a rule when you go through the phenol video, you'll see that's a rule as acyl chlorides will react with phenol, but acids, carboxylic acids, will not. And that leaves 1 and 3, which is C in this case, that will react, and number 2 that will not. And they'll often stick carboxylic acids in there with acyl chlorides because when it comes to phenol, they'll only react with the acyl chloride. Now we're just giving you this as an example, and I hope you got it right. Okay, but if you didn't, most important, you've got to remember all those different reactions. Let's try another one. So which of the following could react with the compound below to form a carbon-carbon bond? So carbon-carbon bonds are in the video carbon-carbon bond formation, okay, which is extending the length of the chain. So if you're not sure about this one, that's a good one to watch. So all we do is we will go along these different ones and see which one and which type of reactions they do. So let's think about it. This number 1, what type of reaction is that? Okay, we can see it's got an acyl chloride in it. We can see it's got aluminium chloride, okay. That means it's acylation and acylation of benzene. So do we have benzene? Yes, we do. So therefore, 1 will react, and that will put a carbon-carbon bond between this C and one of the C's on the benzene. We then look at number 2. Number 2 has got a haloalkane and aluminium chloride. And again, that makes sense. Okay, it makes sense because this is alkylation of benzene, okay, because you've got the aluminium chloride and the haloalkane. So all we need is the benzene for it to react again. Okay, we then got the acyl chloride, or this ethanoyl chloride. Now, ethanoyl chloride will react with phenol. Okay, can you see phenol here? No, okay. It also will react with any form of alcohol. Can you see any alcohol here? No, you can't. So it would normally create some form of ester by reacting with phenol or an alcohol, and there's no alcohol, there's no phenol. So it needs those to react with. Still, no reaction is happening there, okay? So it's really, really important that you recognise that. Just to quickly do as well, we did this by looking at the different functional groups within there. So if you've ever got a question like this, put the functional groups on. Often that will also be questions in the exam because they'll say which functional groups are present here, so practice those, okay? And then you can tell which one of these will react because you know what functional groups are there. Okay, so if that is the case, that means your answer will be only 1 and 2. We'll move on to our last question, which is on level of response. Now this is very, very common as well, so well worth practicing. And normally if it's to do with synthesis, it's a synthesis with a purification and a yield. So what's really good is to remind you of percentage yield. Percentage yield is the actual moles of the product divided by the theoretical moles of the product times 100. Okay, and we're going to use number of moles equals mass over mR, and we'll rearrange that equation so it's mass equals moles times mR as well. Okay, so if you are not familiar with these and you haven't used these before, perhaps you could look at the video on percentage yield, or, okay, if you have seen them before, just note these down now, ready for the next slide. So here is your LOR exam style question, and you can see the different boxes here. We've got 3-step synthesis. So we're going to prepare the product in 3 stages from benzene, and if they're going to do a yield calculation, they'll ask you to base it off the starting material, which is benzene, and the final product. You do not have to worry about the intermediates. So it'll say something like, describe the synthesis of this 3-chlorophenolamine, which we've got here, from benzene. Okay, and so you've got to fill in the boxes and do the reactants and conditions and such. Overall percentage yield is 40%. Okay, so it's going to ask you to work out the initial mass of benzene. So that's why you're going to have to do a yield calculation, reactants and conditions, and the details of purification. Now let's put this to the side And hopefully you've got those three equations already, but let's do the synthesis first. So if we're doing it first, we've got the benzene, okay, and then the benzene is going to go to this first product here. Now, if I want to put, the really, really key thing here is directing groups. So if you see here, this chlorine is on number 3. Okay, 1, 2, 3. Okay, 1, 2, 3. That means whatever group was on here directed that chlorine to number 3. So hopefully you're now remembering what are your directing groups. So now, your two directing groups are OH and NH2, which are 2,4 directing, and your NO2, which is 3 directing. So if we put the chlorine on when the NH2 was there, the chlorine wouldn't be in position 3, it would be in position 2 or position 4. But it's at position 3. So that means the chlorine must have gone on after when this was an NO2. So we must put an NO2 on as our first step. So our first step is going to be HNO3, okay, and H2SO4, both concentrated, okay, and less than 50 degrees Celsius. Now that will then change into our nitro. So we've got a nitro here. Now from the nitro, then we put the chlorine on, because this is going to direct to position number 3, because NO is a electron withdrawing group and it will direct to number 3. So that means we're going to go from there to here, put our chlorine on, and we've got our NO2 there. Okay, now if you go from here to here, you'll need chlorination, which is aluminium chloride, and Cl2. Okay, and then we finish it off with, we've got to turn that NO2 into NH2. So if I draw the NH2 here, there we go. And how did I get from the NO2 to the NH2? Hopefully you remember this is tin and HCl. Okay, so we've done our synthesis. So we've got level 1, for example, of our level of response question. So we've done this one down here. Okay, so now we're going to do the initial mass of benzene. So let's do that calculation. Now we need to use the yield calculation now, so hopefully you've got that equation in front of you. To do that equation, you need the number of moles of the product. So let's now do the number of moles of the product. So if I start here and go number of moles of my product. Okay, so number of moles of my product. I've got a mass of my product, which is 10. Okay, I divide it by the molecular mass, which is 127.5. And I say this in different videos. That is where your mistakes happen normally, because you're in a hurry and you end up calculating the wrong molecular mass. But that is the molecular mass. Okay, then that will equal, okay, 0.0784, and there's your moles. Okay, so there's our moles, 0.0784 moles. Now, that is, if you remember here, a 40% yield. So that's 40% of what I could have, what I made this from. So I need to find out what 100% is. I know that this mass, this number of moles, here, is 40% of the number of moles here. So I need to convert that back to 100. So if I want to know from here, we'll do it with the pink here, our number of moles of our theoretical product, that will be the number of moles of the benzene. Okay, so theoretical of the benzene on theoretical product. Okay, so it's benzene, but it's the theoretical product here. Okay, all I have to do is take this I'll write it in the green, 0.0784 ... divided by 40. I want to convert it up to 100, and then times by 100. Okay, and in the end, this will give you an answer of, let me just get this right, 0.196 and 0.196 mole. Now, noticing here that I'm putting 3 dots after it. So the 3 dots after it is saying, basically, it's a big long number in the calculator, keep it in the calculator. Do not shorten this, do not round this until we get to the end. So these 3 dots are telling me it's a much longer number. Okay, and that's how you put it. Don't do any rounding or anything, just put the 3 dots after it. Now, just to go again, we found the number of moles of the product. We know that's 40%, so we divide by 40 times by 100 to get it back to 100%, which would be our theoretical product because it's the same number of moles as the benzene. And it's a 1-to-1 ratio all the way through. Okay, and that's 0.196 moles. So we now know how many moles of benzene we have. We then need to use the equation, which is our mass. So we want to work out our mass, and our mass in grams is going to be our moles times our NMR. Times our MR. So that would be 0.196 moles times, okay, and our MR, because we've already worked it out, is 78. So that's the MR of the benzene, because we're working out the benzene, okay, and this is our mass of benzene. Okay, we're working that out, that's our 78 of our benzene, and this will equal, things right, 15 as a final answer, let's put it in blue, 15.29 grams, okay, so 15.29 grams. So 1-to-1 ratio all the way through. We've done our synthesis, find out our number of moles of our product, do mass divided by molecular mass, make it back up to 100. This tells me what 100% moles of this is, and because it's a 1-to-1 ratio, that is the number of moles of the benzene. So we've got our number of moles of the benzene, and then we need to find out what is the mass of the benzene, so we times our moles by our molecular mass and get a final answer of 15.29. Right, so now we need to do the third stage, because we've done this stage over here, so we've done the initial mass, and now we're going to do the details of purification and finish it off. So the start we said is a solid. Because it's a solid, it's going to be recrystallization. So you just have to remember what recrystallization is, so try and remember what it is. Okay, so the first thing for recrystallization is dissolve in a, and this is really important, minimum, okay, and that's a minimum amount of, and the next really important bit, hot solvent. Okay, minimum amount of hot solvent. Now after you dissolved it in a minimal amount of hot solvent, you will cool it down. Okay, you will cool it down. After you've cooled it down, you will filter. Okay, and wash. Okay, and that is wash with cold solvent. Okay, so wash with cold solvent. After you've washed with cold solvent, you will leave that to dry. Okay, and leave it to dry. So you've got all 3 levels. So our first level is our synthesis, which relies on directing groups. Then you've got your yield calculation here that finds out the mass of benzene at the start, and then you just describe recrystallization. And that is how you do an LOR question.